terms. So for max terms, the first thing we do is, you notice that the ones that we had earlier are all in blue, and we have put all the other things as 0, which are in a different color, they are in brownish color, right. Now the rows are maintained as they are, 0 0 0 1 1 1 and 1 0, 0 0 0 1 1 1 and 1 0, they correspond to wx and yz, but the interpretation of the rows are now going to be different. So 0 0 corresponds to the sum term w plus x, 0 1 here corresponds to the sum term w plus x bar, this corresponds to w bar plus x bar, and this corresponds to w bar plus x. So remember, this is the logical complement of what we had earlier. So if you want to interpret it in this product form, you would have written it as w bar x bar, but if you want to interpret it in the sum form, it is w plus x. So this would have been w bar and x bar, now you interpret it as w plus x. Similarly, this column would have been y and z if you interpret it in the product form, but in the sum form it is y bar plus z bar. So now we are going to do this with product of sums. In the last example I did sum of products, in this example I will show you how to do product of sums. For product of sums, we are going to group the zeros together. So we have several things now, let us see how to group them. So let us start with what are all the different max terms. Each 0 is a max term. So this corresponds to the max term m naught, capital M0, which is the same as w plus x plus y plus z. You can see that by doing a logical OR of this with this. So w plus x or y plus z, that is the term 0 0 0 0. This term corresponds to the row w plus x and the column y bar plus z. So this is w plus x plus y bar plus z. This term corresponds to w plus x bar plus y plus z, and so on. So if I look at this term, this is w bar plus x bar plus y plus z. So this corresponds to 1 1 0 0. So you must see that somewhere. So this is w bar plus x bar plus yz. So these are all the different max terms. So 1 1 0 0. Oh, sorry, I was looking at a 1, I should look at a 0. Let me pick a 0 here. This corresponds to the term 1 1 and 0 1. So this is 0. So 1 1 0 1 should appear here. 1 1 0 1 is appearing in the list. Okay. So now let us see how to combine them. The same rules as we did earlier apply, except that we are going to group zeros. We are still going to group in powers of 2. We can only group adjacent cells, and for product of sums we can only group zeros. Let us see the various groupings that are there. So this is a grouping because these are 4 ones that are adjacent to each other. So it's a square that we are looking at. Right? There are several other groupings. For example, M4, M5, M6, M7 also forms a group. So this is so let us look at the terms here, M4, M5, M6 and M7, that is this row here. Right? Let us look at this one, M6, M7, M14, M15. So this is M6, this is M6, this is M7, this is M14, this is M15. These 4 zeros are also adjacent to each other, so that is one of the terms and so on. So in this picture I am only showing one of the groupings, I am not showing all the groupings. So this is to get the possible groupings. Now how do you get a simplified expression? We have to cover all the zeros and we want to cover it as few times as possible. This is the thumb rule. We want to cover all the zeros, but we want to cover it with as few groupings as possible and as large groupings as possible at the same time. Right? So fewer but large ones. So let us look at the groupings here. If I started with this one, so I have these 4 zeros taken care of. I still have these 4 zeros and these 4 zeros. So now let us say if I group these 4 together, I will still have these 2 left out. So I cannot expand these 4 into this column because I have a 1 here. Otherwise, if this were a 0, I could have taken all these 2 rows together and combined them into one term. However, I cannot do that now because there is a 1 here. I can only group these 4. Remember, I cannot group 6 of them together, that is not valid. I can only group in powers of 2. So in this case I can group these 4 together, and I will still be left out with these two zeros here, but they are in this column containing all the zeros. We can group all of them together also, and we get various terms. So this grouping, right, is M0246. So this is 0, this is 2, this is 4, this is 6. So we can, this grouping is this sum term, and this grouping here corresponds to this sum term, and this grouping here corresponds to this sum term. If you notice, all the zeros are covered at least once, and we have tried to cover it with as large a zero group as possible, which is still a size of powers of 2. So these are the three different sum terms that we get: M0, M2, M4, M6, M5, M7, M13, M15, and M2, M6, M10, M14. These are the sum terms that we get. Now we can go and write the expressions for this directly by looking at M0, M2, M4, M6. So let me show you how to get the corresponding expression for M0, M2, M4, M6. M0, M2, M4, M6. So the product term that, so remember this is a set, it is not a product of these four. So the sum term that corresponds to this should have this one, right. So in some sense you go and look at this one. So this is W plus X plus Y plus Z. M2 is W plus X plus Y bar plus Z. M4 will correspond to W plus X bar plus Y plus Z, and M6 will correspond to W plus X bar plus Y bar plus Z. If you look at these four terms, right, you can notice that what we are having is this W is appearing in the same form in all the four. So you can notice that here W is appearing in the same form everywhere, and Z is appearing in the same form everywhere. So the combination of these four is actually just W plus Z. Right? You can infer that by coming back and looking at the table here. So these two rows have W in common. So the sum term should have W. If you look at these two columns here, which this has Z in common, this is Y plus Z and Y bar plus Z. So these four cells have W plus Z, and similarly these four cells we have X bar in common, and in these two columns we have Z bar in common. So these four cells correspond to X bar plus Z bar. Finally the last column here, W and X are continuously changing, but this corresponds to the term Y bar plus Z. So this one is W plus Z, this one is X bar plus Z bar, and this last column is Y bar plus Z. You can write that as a simplified Boolean expression, W plus Z into X bar plus Z bar into Y bar plus Z. So in this example we have grouped the zeros together and we got a product of sums. So let us look at some more examples from here. So if I have a table like this, right, this is a expression where we have, it is a function of X, Y and Z. Let us assume that X is the leftmost variable and Y, Z appear in the next two columns in the truth table. If I want to group them together, right, the sum of products will be grouping all the ones together. So we have a group of 4, and in this group of 4 it corresponds to Z being 0 as a column, so it is Z bar, and this one is still left out. I have to group that also. When I do that, I get the term X bar Y, because it is in the row X complement, but it is across two columns where Z is flipping but Y is constant at Y, right, it is X bar Y. So it is Z bar plus X bar Y. If you want the same thing in product of sums, you group the zeros together. So if I group these two zeros together, that will correspond to the term Y plus Z bar, and if I combine these two together, it corresponds to the term X bar plus Z bar, sorry, Z bar, because Z is 1 here. So this row corresponds to X bar, these two columns correspond to Z bar, so it is X bar plus Z bar. You can actually go and take this expression and simplify it, you will end up with the expression on the left side. So you have product of sums and sums of products right. In this example, if you want to implement this using gates, the z bar plus x bar y will require two inverters, because for z and x you need inverters. There is one AND gate here and one OR gate here. So we have two inverters, one AND and one OR gate. So this 2 here implies it is a 2 input gate. If we do the product of sums, we need two inverters, one for z bar and one for x bar. We need one AND gate to do this product, but we need two input OR gates, one for this term and one for this term. So in this example, right, it looks like this one needs 4 gates and this one needs 5 gates. So for example 1, the sum of product expression, this way of simplifying is better rather than this way of simplifying it. Let us look at one more example. So this is an example in which we have 4 variables w, x, y and z. Let us group the ones together and get sum of products first. So let me show you the one which is not grouped. We can see that there is a group of 4 ones here, there is a group of 4 ones here, there is a group of 4 ones here, there is a group of 4 ones here and so on. There are several groups of 4 here. So let us pick all the things that we need. So there are 4 groups of 4 here. So this term corresponds to w being 1 and y being complemented. So you have w y bar. This column here corresponds to y being 0 and z being 1. So you have y bar z. This row here corresponds to w being 1 and x being 1. So you have w x. And finally this group of 4 corresponds to x being 1 and z being 1. So you have x z. So f of w x y z is w x plus w y bar plus y bar z plus x z. So this is a very simplified expression for this truth table that is given here, or the K map that is given here. So if you do the product of sums, the product of sums will require you to group the zeros. So there is a group of 0 here and a group of 0 here, that is 2 groups of size 2, so it makes it a group of 4, and there are 2 groups of size 2 here which can be combined to make a size of 4. So you look at this term here and this term here, right, that corresponds to the fact that w is 1 and these 2 columns correspond to the fact that z is 1. So the intersection of that gives you w plus z. And if you look at this grouping here, this corresponds to the fact that x is 1 and these 2 columns, so these 2 rows correspond to, so the first row and the last row correspond to the fact that x is 1 and the last 2 columns correspond to the fact that y is 0. The intersection of that gives me x plus y bar. So this is the sum of product and this is the product of sum. In this case you will need 1, 2, 3, 4 AND gates, 1, 2, 3 OR gates and 1 inverter, right. Only for y you need an inverter. So 1 inverter, 4 AND gates and 3 OR gates, whereas in this one you need 1 OR gate here and 1 OR gate here, 1 AND gate here and 1 inverter there. So 1 inverter for y bar, 1 AND gate for the product and 1 AND gate for the product and 2 OR gates for the individual terms. So in this example it so turns out that the POS is smaller. Upfront you may not be able to say whether SOP is better or POS is better. In this example POS is better, in the previous example SOP form was better.